So our next example, number 3, find the absolute extrema for okay, here we are again. Sorry for that. Okay, the absolute extrema. We need a derivative. We'll start with that. We'll need the quotient rule. So derivative of the numerator is a 1 times the denominator minus the derivative of the denominator, which is a 1 times the numerator. All divided by denominator squared. So this is x minus 2 minus x over x minus 2 squared. That's just a negative 2 over x minus 2 squared. Okay, so as we can see, this function is never 0. Okay, I mean, this derivative function, if you set it equal to 0, and you try to find this, where is that 0? Well, it's not, because the negative 2 in the numerator would have to be a 0. So it's not 0. Where is it undefined? Well, it'd be undefined at x equals 2, because the denominator would be a 0. But x equals 2 is not in the domain for this function. Okay, it's not in the domain. So that x equals 2 is actually what we would call, you might recall, it's a vertical asymptote. Now, so that doesn't affect us. There are no critical numbers. Does that mean it doesn't have any extrema? No, because this is a closed interval. And if the function is continuous on a closed interval, this is continuous on this interval 3, 5, because the asymptote is not in here. So this will have a max absolute and a min absolute. But there are no critical numbers. So those must occur at the endpoints. We don't know which one is which. We'll find out. So let's compute f of 3. We get 3 over 3 minus 2, which is 3 over 1, which is 3. F of 5 is 5 over 5 minus 2, which is 5 over 3. So I think we can see now, here's our absolute maximum, and here's our absolute minimum. It occurs at 5. When x is 5, we have an absolute minimum of 5 over 3. Absolute maximum occurs when x is 3. So essentially what we're seeing here, and this isn't necessary to the problem, but I want you to see this. At 2, you have that vertical asymptote. And at 3, you have a value of 1, 2, 3 right here. At 5, you have a value of 5/3, which is 1 and 2/3. So at 3, 4, 5, it's about here. So what we're looking at is this function, and you can see how the graph comes in, like so, roughly, okay? And we're only looking at this window here. This is the only thing that we're considering, from here to here. So you can see that the maximum does occur over here on this endpoint and the minimum over here, because that's literally the highest point on the graph here and the lowest point on the graph. So that's all we're looking at. Doesn't matter what the rest of the graph looks like. For this interval, this is true. We have our absolute maximum and absolute minimum. And notice no relative extrema.